Okay, today we shall be talking about causality between export and GDP, a case study of Maria Land. Meaning that today there are two variables such as export and GDP. So export means export and GDP means gross domestic product. And today we shall develop a causality model between export and GDP. Okay, so our model, we have two variables such as export and GDP in a country like Maria Land, and the model is a time series model from 1980 to 2010. So this model is a time series model, and this model is a causality model between two variables. Objective, our objective is to check whether there exists causality between two variables such as export and GDP. Then I talk about natural log. Here we can convert two variables into natural log for statistical reason, such as to avoid heteroscedasticity. That means we can convert the variables into log. We can convert the variables into log to avoid the heteroscedasticity. Here we can convert two variables into log for statistical reason, such as to avoid heteroscedasticity. And if the variables are in log form, so it will estimate elasticity all the time. Normally when the variables are in log, meaning that we are estimating the elasticity. But here we have not converted two variables into log, meaning that we have not converted our two variables such as export and GDP into log. Okay, then we talk about unit root test. Okay, since most of the variables or series are non-stationary, unit root tests are useful to determine the order of integration of the variables. Okay, suppose our two variables export and GDP had unit root at level, but after first differencing they become stationary. So here we assume that our two variables had unit root at level, but after first differencing they become stationary. So that we assume that but we have not done the test. I just assume that. Okay, here we can use the augmented Dickey-Fuller test to check the unit root. The typical augmented Dickey-Fuller test is given below, which is equation 1.1. So meaning that this one is the augmented Dickey-Fuller test 1.1. Okay, but here I'm not testing the unit root, but just assuming that export and GDP become stationary after first differencing. So we are not testing at all, just assuming that GDP and export become stationary after first difference. But at level they are non-stationary. At level they are non-stationary, but when I do the first difference, then they become stationary. That I just assume. Okay. Then after testing the unit root, then I go to test of cointegration. What is this? If the variables are integrated of the same order, we can apply the Johansen-Julius maximum likelihood method of cointegration to obtain the number of cointegrating vector. So that is the guideline. If the variables are integrated of the same order, only then we can perform test of cointegration by using Johansen-Julius test. Okay, Johansen-Julius approach is preferred over Engel-Granger method due to statistical reasons. And since export and GDP are integrated of the same order, we can apply the Johansen-Julius maximum likelihood method of cointegration to obtain the number of cointegrating vector. Johansen-Julius multivariate cointegration model is given below, equation 1.1. So this one 1.1 is actually Johansen-Julius multivariate cointegration model. And here in this model, in the model 1.2, where xt is the 2-1 vector, that is export and GDP respectively, and delta is a symbol of difference operator, et is a 2/1 vector of residual. The VECM model has information about the short run and long run adjustment to changes in xt via the estimated parameters respectively. Here the expression, this one means this one, right? Here the expression is the error correction term. So this one is the error correction term, right? And alpha can be factored into two separate matrices, alpha and beta, such that alpha equal to beta, where beta denotes the vector of cointegrating parameters, while alpha is the vector of error correction coefficient, measuring the speed of the convergence to the long run steady state. So this one is actually Johansen-Jusselius test under var environment, under vector autoregressive environment 1.2. So okay, and our variables, and what we have done, we have tested the test of cointegration by Johansen-Jusselius method, and after testing, our variables export and GDP are found to be cointegrated after running Johansen-Jusselius, meaning that they share a common stochastic trend and will grow proportionately. In other words, they move together in the long run, or they have long run relationship. That means after running the Johansen-Jusselius test using export and GDP, it has become cointegrated, meaning that these two variables have long run associationship. Okay, then I talk about Granger causality test. If the variables are found to be cointegrated, we can specify an error correction model and estimate it using standard methods and diagnostic test. Okay, that means when the variables are found to be cointegrated, then there is a error correction term should be there. Okay, but here in case of cointegration indicates that causality exists between the two series or between the two variables, but it fails to show us the direction of the causal relationship. Engel and Granger suggest that if cointegration exists between two variables in the long run, then there must be either unidirectional or bidirectional Granger causality between these two variables. Okay, so the what does it mean? It means again I am telling, Engel and Granger illustrates that the cointegrating variables can be represented by an error correction mechanism representation. Okay, I'm telling the whole thing again. In other words, according to the Granger, if there is a evidence of cointegration between two or more variables, then a valid error correction model should also exist between the two variables, right? Okay, now we talk about our model. As export and GDP are co-integrated, that we have already found, a VECM model could have the following form in equation 1.3 and 1.4. So this one is the first model, right? Error correction model, and this one is the another error correction model, and so that is 1.3 and 1.4. And here you can see this one is the dependent variable GDP, and these are all independent variable, right? The two variable are here, and this one is the another dependent variable, and these are all independent variables in equation 1.3. Okay, here beta 1, alpha 1, m1 and n1 are the short run coefficient, meaning that this one, this one, this one and this one, these are all the short run coefficient. And what about this one? This one means number of lag, right? Here is the number of lag. And EC1, EC2 are error correction term, and E1T, E2T are residuals in the equation 1.3 and 1.4 respectively. Here this one EC1 actually error correction term of this model 1.3, and EC2 is the another error correction term of the model 1.4. Okay, then the EC1 T minus 1 is the lagged value of the residual derived from the cointegrating regression of GDP on export, right? Meaning that this part is very important. How to get this value? How to get this value? This value actually is the residual that we have taken from the cointegrating model of GDP on export, meaning that when we run the cointegrating model between GDP and export, where GDP is the dependent variable and export is the independent variable, so from there we take the residual. From there we take the residual, and after taking the residual, then we make one period lag. We make one period lag of the residual and put it here. So this one actually is the one period lag of the residual of the cointegrating model between GDP and export. And in the similar way, while EC2 is the lagged value of the residual derived from the cointegrating regression of export on GDP. That is equation 1.4. That means we follow the same thing. First we run the cointegration between export and GDP, right? And after running the cointegration, so we can get the cointegration model, and from that model we take the residual, and what we do, and after taking the residual, we make it one period lag. We make it one period lag and we put it here. So that is called EC2 T minus 1. Okay, so this one is our error correction model. It is number 1. It is number 2. Okay. Then how to estimate result? Then unidirectional causality from export to GDP, that is export Granger cause GDP, will occur in the equation 1.3 if the set of estimated coefficient on the lagged export coefficients are non-zero. So I'm saying again, unidirectional causality from export to GDP, it means export Granger cause GDP will occur in the equation 1.3 if the set of estimated coefficient on the lagged export coefficient are non-zero, and the whole thing is called short run causality, meaning that if this one is non-zero, meaning that export can cause GDP in the short run. I am telling again, if alpha becomes 0, meaning that export can cause GDP in the short run, or this one is really short run causality from export to GDP. Okay, and the error correction coefficient, which is Z1 star of ECT1, is significant, and that is called long run causality. What does it mean? It means that if this one is significant, EC1 T minus 1, that one significant means, that means export has a long run causality on GDP. So this one is the long run causality, and this one actually short run causality, meaning that if the Z1 is significant, meaning that export can cause GDP, and that is called long run causality. And if alpha 1 is significant, meaning that export has a short run causality on GDP. So okay, I'm telling the same thing here. The next one is the same thing. Similarly, unidirectional causality from GDP to export, GDP Granger causes export, will occur in the equation 1.4 if the set of estimated coefficient on the lagged GDP are non-zero, so that is short run causality, and the error correction coefficient Z2 of EC2 is significant, then that will become long run causality. Meaning that in the second equation 1.4, so here if the M is significant, right, meaning that there is a short run causality from GDP to export. Okay, and again, if EC2 is significant, then there is a long run causality from GDP to export. Okay, so it is done. Then finally, if both variables Granger causes each other, then it is said that there is a two-way feedback associationship between export and GDP, meaning that we call it bidirectional associationship if all the coefficients are non-zero. And here we said that error correction term has long run information as it is derived from the long run cointegrating relationship. So this one is the model, the causality model between two variables. One is export and GDP.